Hello and welcome to Cannon County High School Algebra 2. We've only got a couple of days left of these videos, so I thought we would spend the last 2 days talking about scatterplots and linear regression. Both of these things you may have seen in Algebra 1. I'm sure that you've done scatterplots before, but I'm not sure you did linear regression in Algebra 1. So if this is review, it's a good review, and if you've never done it before, well, you're going to learn something new. So let's take a look at, well, by the way, Mr. Lyon, we'll see tomorrow what happens. Hopefully you get some freedom. See how that goes. Let's say you are in the market for a different car, and you've been deciding, you know what, I kind of like those Toyota Camrys, so I'm going to get myself a Toyota Camry. And so you do a little research, and you find some prices of Toyota Camrys, and you notice that there is a relationship between the year that the car was made and the price. And you decide, well, let's see, you look and you got 2004, you found a price of $4,800. And as the car gets newer and newer, you see a 2018, which is only a couple of years old. It's all the way up here to $17,400. And you want to get a good idea of what happens to the price of a Toyota Camry over time. And we're going to do that by making a scatter plot, doing a little bit of linear regression, and see how the linear regression can help us make predictions about the price of a car, okay? And so what we're going to do first is just take these points and put them on a scatter plot. Now I'm going to show you how to do this eventually on the calculator, but I think you'll understand it better if we do it by hand first. We're just going to actually plot some points on a graph. Here's the year of the car, 2005 up to 2020, and here's the price of the car from $5,000 up to $20,000. And we're just going to plot these points and see if it looks like they have a linear relationship. So let's see. Let's start out here. 2004, $4,800. So let's plot that point here. 2004, $4,800. We're not being precise. This isn't graph paper. We're just kind of getting close. All right, let's see. 2007, $7,200. So 2007, $7,200. Let's say that's right about there. Let's see, 2010 is $8,100. 2010, $8,100. 2013, we're up to $9,000. That's just a little bit shy of right about there. Jumping all the way over to 2017, we're at $15,700. So at 2017, 2017, there we go. We're all the way up here to 15,700, so that's a little bit above that line. We're way up there. And then finally, 2018, we're at 17,400. So 2018, we're up here at 17,400. Let's put that one right about there, I guess. Okay, so there's our scatter plot, and you can see that it looks like the price of a car and how old it is do have kind of a linear relationship. And here's what linear regression means. Since these don't follow a perfect line, I can't take a ruler and put it where it goes through all the points, but they do kind of follow a line. And our job then is to find out what is the absolute best line that models this data. And believe it or not, your brain does a pretty good job of doing this, because your brain can do things that sometimes a calculator, it's really difficult for a calculator to do, and your brain just does them naturally. For instance, if I were to say, what's the linear relationship going on here? If I were to put the ruler like this, you would say, no, that's not it. And what I'm going to do now is just ask you to tell me, where should I stop? As I rotate this, you tell me, where should I stop? And boom, naturally, you're going to say it looks like it's something like that. It looks like if we were to draw a line kind of like this, some of the points are going to be above the line, some of the points are going to be below the line, but it looks like that line right there is a pretty close representation of what's going on. That's called linear regression. In linear regression, what you actually are trying to do is to minimize the distance that each of these points is away from the line. You can see some of these points are almost touching the line, and others are really, really close. But when you do linear regression, you want to minimize those as much as possible. In other words, you want to make the standard deviation as small as possible. Okay? So now we want to figure out the equation of that line. Okay, and how do you find the equation of a line? Well, there's lots of ways to do that. The one way that you learned how to do that in Algebra 2 is just by taking 2 points and figuring out the slope and then using the point-slope form, and that's what we're going to do now. So let's see, this point right here looks like it's pretty close to being right on the line, and if you remember correctly, that was the point 2017, 15,700. So this point right here is the point 2017, $15,700. That was that point. And it looks to me, so we're going to look at that point, and this point right here also looks like it is pretty much on our line. And that was the point 2007, 7,200. 2007, 7,200. And so now let's just figure out the equation of this line using a little bit of Algebra 1. You know that the slope of the line is equal to y2 minus y1 over x2 minus x1, right? Remember that formula from Algebra 1? So what would that be? That would be 15,700 minus 7,200, all divided by 2017 minus 2007. So let's bust out the calculator and see how this goes. 15,700 minus 7,200, and that equals 8,500. So that's 8,500 divided by 2017 minus 2007, that's 10. So our slope, if we divide by 10, that's going to be 850. Okay, there's the slope. So what do you do next? Well, you remember the point-slope form from Algebra 1, y minus y1 equals m times x minus x1. Maybe you don't remember, but it's all going to come back to you in a minute. You choose one of the points, and you take the slope, and you plug them into the formula. And what we want to do is we want to write this in slope-intercept form, y equals mx plus b. That's the one I know you remember from Algebra 1. So let's do this. Let's take this point. The numbers are a little smaller, and see how this goes. So y minus y1, which is 7,200, equals our slope, which we said was 850, times x minus 2007. And we're going to do a little, let's see, we're going to distribute here, so that's going to be 850x minus, well, I don't know what that is on my calculator, so, or in my head. Let's see, 850 times 2007 is, oh boy, that's a big number, 1,705,950. 1,705,950. Okay. And we're almost there. We want to get y all by itself, so that means we have to add 7,200 to this big number over here. So y is going to equal 850x. And let's see, if I take that number right there, and let's see, negative 1705950, and add to it, let's see, I have to add 7,200, don't I? I have to add 7,200 to that negative number, so I'm going to plus 7,200, and that equals negative 1,698,750. There we go. That is our equation. That is what we did using linear regression. Now, can you do that on your calculator? You sure can. Here we go. Let's try it. Let's see how close we got using our eyeballs to what the actual value is. Here's how you do it on a calculator. I'm going to go back to my points here. And on your calculator, I'm going to zoom in on the calculator here a little bit so you can see this. I'm going to put these numbers into the calculator. The place I'm going to do that is if you hit the stat button, which is this one right here, hit the stat button, and you can see where it says edit. Make sure that's highlighted, hit enter. And see, it brings up L1, L2, L3, L4, and L4. So L1 and L2 are the two that we're going to use. I'm going to put in our data. 2004, enter. 2007, enter. 2010, and so on. 2013, 2017, 2018. And then I'm going to use the right arrow key, right here, and I'm going to do that, and it's going to bring me up to the top of L2, and now I'm going to enter my prices right here. So let's see, that's going to be $4,800. Oops. Do that again. 4,800. There we go. 4,800, 7,200, 8,100, 9,000. Oops, that's too many. There we go. 15,700. And finally, 17,400. There, so I've entered my data into the calculator. Next, I want to change my window so that I can actually see where this data is plotted. So I'm going to hit Window. All right, and look at what we did on paper here. It looks like for the X, we went from about 2000 up to 2020. So that's what we're going to do here. We're going to go from 2000 up to 2020. And for the Y values, let's see, it looks like we went from, well, let's just go from 0 all the way up to 20,000. So let's start at 0 for the Y minimum, and for the Y maximum, let's make that 20,000. And now if I hit graph, you can see I have my graph, but I don't have any points plotted. And the reason for that is this button here, the second function of this button says stat plot. I need to actually turn, oops, you didn't see that. The second function of the very uppermost button on the left says stat plot. I have to actually turn my stat plot on. So I'm going to hit second and that button. You can see that right now my plot 1 is off. So if I use the arrows here, turn that on, hit enter, now my stat plot is on. So now when I hit the graph button, I don't know how well you can see that. Yeah, you can see that all right. You can see that looks very similar to what we did. Doesn't that look a lot like that? Very similar, right? Almost the same thing. A little more accurate than we did by hand, but that's what it is. Now, wouldn't it be nice if this thing would automatically be able to calculate for us the perfect linear regression line in slope-intercept form? Well, that would be nice. And in fact, tomorrow I'm going to ask you to do that on the IXL, and it's going to ask you to round each one to the nearest thousandth. We'll worry about that tomorrow. But for right now, if I want to figure out the perfect line that goes through there, all I have to do is hit Stat, move this over to Calculate, and you'll see it says one variable statistics. Now this is the free app on your phone, and so it's only going to allow you to do the one variable statistics. Notice a lot of these things are grayed out. You'd have to pay money to get the rest of these regressions. There's a lot of things other than linear regression, but notice they do give us linear regression, choice 4. So go down to choice 4, highlight that where it says linear regression, hit enter, and it will give you this. It gives you just brings this up like this, then just hit enter again, and notice what it gives you. You might have to scroll down on your phone to see this. The iPad has a bigger screen, but it says y equals ax plus b. Why they're using a instead of m, I don't know, doesn't matter. But they're telling us this is the slope, and this is the y-intercept. So what does that mean? Okay, this is what we came up with, and this is what the calculator came up with. 862.5x minus 1,724,634. Okay, so with our eyeball, we came up with this one. And the calculator, perfectly making the standard deviation as small as possible, came up with that one. So you can see this A and B. Now this number here, this R, is called a correlation coefficient. That tells you how close the data actually is to the line. The closer that number is to 1, the more perfect the data is. If all the points were perfectly on the line, R would be 1. If there was no correlation at all, if it was just a bunch of random points and it had to find a line, then it would be 0. So the closer the correlation coefficient is to 1, the better the numbers are. So you can see by hand, we came up with something I would say we did pretty well. 850 is the slope, 862. This number and this number, they're not that bad. So you might say, well, how can I use this then? You can use this then to make predictions. For instance, one car that we did not have on here was a 2015. We had a 2013, we had a 2017. Let's say you found a 2015 and you wanted to see if the price that they were asking was in line with what they should be asking. So all you'd have to do is, well, let's take the perfect one here and let's plug in a 2015 right there. So on your calculator, you could just type in 862.5 times 2015 minus 1,724,634. And according to our linear regression model, they should be asking $13,304 if we rounded it off. So a 2015 should be this much. So what you use linear regression for is to make predictions. Now, I'm not going to have you do any IXLs today. I want to go over this a little bit more with you tomorrow before we do that. But what I'd like you to do today is just, because I know it was hard for you to do this on your calculator as I was doing it, see if you can do the same thing we did. Take these numbers and plug them in and see if you can recreate this equation right here by using the same method. You might have to go back and rewatch or pause the video on certain points so you can see what I'm doing, but it's important that you're going to know how to type this into the calculator to get that linear regression, okay? So give that a try, see if you can get the same equation that we got, and we'll talk a little bit more about this tomorrow on how the calculator can help, okay? If you have any questions, put them in the comments. Thank you for watching. We'll see you tomorrow. Tomorrow's the last day. Bye.